is a scalar, which is a sum of the product of the corresponding coefficients. 3 times 5 plus 6 times -2 plus -4 times 3. -24 plus 15 is -9. You notice, no i's, no j's, no k's. This is not a vector. Number 2, the same vectors. We want u cross v, which is the determinant. The first row is I, j, and k. And the second and third rows are the coefficients of the vectors. Expanding that, we get 6 times 3 is 18, subtract 8, 10 times I, plus j, -20, minus 9, and 0.9j, plus k, and -6, minus 30, -36, k. And I minus 29j minus 36k. Who can? Blank. Okay, it's not that bad. Saunders. Complex number operations in rectangular form. 3 minus 6i plus 6 plus 5i. We add the real number parts, and we add the imaginary number parts. Nah. Yeah, you don't want to see me angry. That's a rare event, but you don't want to see me angry. Okay, number B says 2 minus 7i, subtract 4 plus 7i. 2 subtract 4 is -2. -7i subtract 7i is -14i. Number C, we have 4 minus 7i times 4 plus 3i. And use distributive property or FOIL, whatever. 16 plus 12i minus 28i minus 21i squared. And this behaves like positive 21. 16 and 21 is 37. 12 subtract 28 is -16i. And finally, choice D, we have 3 minus 5i divided by 1 minus 4i. So we choose to multiply by the well-chosen 1 plus 4i over 1 plus 4i. Numerator, oh, let's do the denominator. Denominator gives us 17. Numerator, the real number part, 3 plus 20, 23. Imaginary part, 12 minus 5, 7. Number 5, perform each of the following complex number operations in polar form. First one says 11 cosine theta times I sine theta, where theta is 24 degrees, times 3 is 137 degrees. And in polar form, to multiply, we multiply the magnitudes, and we add the angles. number B, 22 cis 56 degrees divided by 6 cis 29 degrees. Is that right? 29 degrees. And in doing division, you divide the coefficients and subtract the angles. Let's see, 30, 26, 27, 27 degrees. And part C on that one, raising to a power, 4 cis 37 degrees to the 4th power. So that will be 4 to the 4th cis, 4 times 37. 4 to the 4th is 256. 4 times 37, 74, 148. 148 degrees. Okay. Now it says find the 5/5 roots of 31 cis, or 3125 cis 70 degrees. So what we do is find a principal root, and then since there are 5 that we have to find, they're equally spaced over the remainder or over the circle. So a little arithmetic on the side, 360 degrees divided by 5, they're 72 degrees apart. So if I have x to the 5th equals 3125 cis 70 degrees, if when we do powers, we raise the coefficients of the power, when we're doing roots, we'll take the 5th root. And the 5th root of 3125 is 5. And when we're doing powers, we multiplied the exponent, or the angle. So when we're doing roots, we will divide the angle by 5. So that's our principal solution. And then the others are 72, 144, 216, and 288 beyond that. 5 cis 86 degrees, 5 cis 158 degrees, 5 cis, let's see, 272, 230 degrees, and 5 cis 302 degrees. So we have 1, 2, 3, 4, 5 solutions. Part B, or page 2. Sketch each of the following graphs. Plus 3 times the cosine of theta. You should recognize the general formula as what we call a length sum. In this particular case, it's a cardioid. So we plot the 4 cardinal directions. 0, pi over 2, pi, and 3 pi over 2. In the direction of 0, cosine of 0 is 1, 1 times 3 is 3, 3 plus 3 is 6. In the direction of pi over 2, cosine pi over 2 is 0. That goes away, we have 3. In the direction of pi, cosine of pi is negative 1. That's negative 3. 3 plus negative 3 is 0. In the direction of 3 pi over 2, cosine is 0, so we get 3 again. And number is easy to pick. Cosine of 60 degrees and 120 degrees and 240 degrees and 300 degrees, all are nice numbers. Cosine of pi over 3, 60 degrees, is 1/2, so we get 4.5, 3, 4.5, and down here we'll also get 3, 4.5, and this way we'll get 3 minus 1.5, or about 1.5, and this way we'll get about 1.5, and we connect all those with a smooth curve, and we end up with a shape like that. And we need scales and labels and general shape. All will be somewhere in the ballpark, so to speak. And that's our curve. Number 8 is in the form of a pedal curve, or sine 3 times theta. So that's the magnitude. This tells us where it begins. That is, where is the top of the first leaf, so to speak. And sine is maximum at 90 degrees. So on the side, if I say 3 theta equals 90 degrees, then theta equals 30 degrees. That tells me that in the direction of 30 degrees, we have our first leaf. And since there are 3 leaves equally spaced, 30 plus 120, and 150 plus 120. So we end up with, draw very well, and if we encompass some circle around that, that is 4. This is direction 0, 90 degrees, 180 degrees, and 70 degrees. So it should be a nice pre-bladed propeller, so to speak. Ideally, all the pedals are the same shape and magnitude. Okay. Numbers 9, 10, and 11 are talking about conic sections in standard forms. So let's see if we can figure them out. Number 9 says, number 9, write the equation of a circle whose center is at 1-2, and whose radius is 5. So, x minus h squared plus y minus k squared equals r squared. That's the equation. Number 10, write the equation of an ellipse. The equation of an ellipse whose center is at 2, 3. Semi-major axis in the x direction is 5, and then the semi-minor, it said. Let's say semi-minor is 3. So again, x minus h, semi-major squared, plus y minus k squared over semi-minor squared is equal to 1. Okay, parabola has that form if it's in the opens vertically. And here we're told that the parabola has its vertex at 2, 3. So it's going to be x minus 2 squared is equal to 4 times p times y minus 3. Have to figure out what p is. It tells us that the vertex is at 2, 3, but the directrix is 1. Well, if we do a little counting, 1, 2, 1, 2, 3, there's the vertex, and here's the directrix. That distance is p. That is 2 units. So my final equation x minus 2 squared equals 8 times y minus 3. Okay, and number 12 says sketch the graph of the polar conic. R is equal to 2 over 1 minus, does that say 2/3? 2/3 of the cosine of theta. Okay. So again, we do our cardinal directions. Direction of 0, cosine is 1. 1 minus negative 2/3, negative 2/3. 1 minus 2/3 is 1/3. 2 divided by 1/3 is 6. In direction of 90 degrees, cosine of 90 is 0, so we have 2 over 1. In direction of 270, have 2 over 1. Direction of 180, cosine of 180 is negative 1. Negative 1 times negative 2/3 is positive 2/3. 2/3 plus 3/3 is 5/3. 2 divided by 5/3 is 6/5. Put that there. By symmetry, since one focus is here, that is 6/5 from a vertex. The other focus will also be 6/5 of the vertex, and there it'd be up 2 and down 2, which gives us a few more points to make our sketch go through as we sketch in our rugby football. 6, 2, 2, 6/5. Direction number 0, pi over 2, pi. And the last one says find the sine and cosine of the angle necessary to rotate the axis to eliminate the xy term. In the general conic, as long as you're not throwing them violently at me, feel free to throw it at anybody else. That probably, I shouldn't say that because someone will take you up on it. He looked at me funny. Okay, so we have the general conic, 2x squared plus 4xy minus y squared plus 3x plus 5y minus 6 equals zip. Okay. So the critical factor that we're looking for is we want to find the tangent of twice theta, which is b over a minus c, where the coefficients are a, b, c, d, e, and f. So in our case, we have 4 over 2 subtract negative 1, positive 3. So this is the tangent of 2 theta. Do a little sketch on the side. 2 theta gives me potential sides of 4 and 3, which means the hypotenuse is 5. So the cosine of 2 theta is 3/5. And if the cosine is 3/5, then the cosine of theta, square root of 1 plus cosine 2 theta over 2, which is equal to square root of 1 plus 3/5 over 2. 5/5 plus 3/5 is 8/5 divided by 2 is 4/5. The square root of 4/5 is 2 over square root of 5. And in a similar fashion, over here, sine of theta equals square root 1 minus the cosine of 2 theta. 2, square root of 1 minus 3/5 over 2. 5/5 minus 3/5 is 2/5. Divided by 2 is 1/5. 1 over 5. So, that was exam 3. Again, if you feel like that I have seriously erred in